awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita akan discuss lagi dua soalan sambungan daripada video yang lepas berkaitan dengan soalan linear motion graph. Okay, tapi sebelum tu kalau siapa tak pergi tengok lagi video-video ini, ada 3 video. Okay, short notes animation 1, 2, 3. Okay, and then you boleh tengok juga. Okay, untuk video Academy Revision ini, saya juga ada bincangkan nota berkaitan dengan kinematics of linear motion graph. Okay, jadi apa tunggu lagi? So, jom kita mula sambung soalan nombor 3. Alright, so example number 3. So, let's read the question. So, here we have figure 1 shows a velocity against time graph, VT graph for an object. So, based on the graph, so A, calculate the acceleration of the object within the first 3 seconds. Means that from 0 second here to 3 second. Okay, so always remember the gradient of VT graph akan bagi you nilai acceleration. So, jom kita tulis. So, question A. So, we can write that acceleration, okay, is actually the gradient, okay, the gradient of VT graph. Okay, and then we want 0 to 3 second. So 0 to 3 seconds. So this is the gradient from 0 to 3 second. Okay, so acceleration, okay, y2 minus y1, okay, gradient over x2 minus x1. So it's actually 6 minus 0 over 3 minus 0. And then the answer is equal to 2 meter per second squared. Okay, and it is a positive value. Why? Because the object is moving in positive direction. Look at the value of the velocity. From 0 to positive 6 meter per second, so the object increase its velocity. Okay, in 3 second, velocity dia meningkat. And the value, okay, awak tengok dia punya magnitude, nilai dia 0, 1, 2, 3 semakin meningkat, and then the value is positive, means that it's moving towards positive direction. Okay, V is increasing, so object itu mengalami pecutan, accelerate in positive direction, so it is 2 meter per second squared. Alright, so finish A, and then B, okay, saya tulis kat tepi ni. Sketch acceleration against time graph for the object. Alright, so now we want to determine what is the gradient for this one, this line. Okay, sorry, this line from 3 to 4 second. Okay, so let's say this one is from 0 to 3 second. Okay, and then from 3 to 4 seconds. Okay, 3 to 4 seconds. Okay, kita kira dekat bawah ni lah, sama juga acceleration dia. Okay, jadi kalau saya tengok dekat sini, look at the green color. The gradient here will give you the negative value. Means that the acceleration is negative. Okay, kenapa negatif? Sebab velocity dia semakin berkurang. 6, 5, 4, 3, 2, 1, 0. Okay, tetapi nilai velocity dia masih positif. Means that object itu masih bergerak in positive direction, but this time the velocity is decreasing. Okay, the velocity is decreasing. That's mean dia decelerate. Okay, decelerate in positive direction. Okay, so nanti nilai acceleration you akan dapat negatif sebab dia decelerate in positive direction. And this one, V is increasing because the object is accelerating ataupun accelerate in positive direction. Okay, positive direction tu kalau ke kanan positif, ke kiri negatif. Ke atas positif, ke bawah negatif. Okay, so bila saya kira acceleration, okay, the gradient of the graph. So 0 minus 6. Okay, tengok sini lah. This is initial point and this is final point. So the y-axis 0 minus 6 and the x-axis is 4 minus 3. Okay, so saya percaya you tahu cara nak kira gradient of the graph. So saya dapat dekat sini negative 6 meter per second squared. Okay, so ini nilai yang saya dapat lah. Alright, and then from 4 to 6 second, So look at here, what happened from 4 to 6 seconds? Okay, so from 4 to 6 seconds, okay, the value of the velocity is negative value. Alright, negative value, tetapi nilai dia semakin meningkat. Start from 0, 1, 2, 3. 0, 1, 2, 3. Maknanya dia punya magnitude dia tu semakin bertambah. But the direction of the motion, since the velocity here is negative, means that the object is moving in negative direction. Okay, mungkin dia patah balik ke? Okay, so kalau saya tulis kat sini, V is increasing in negative direction. Okay, jadi kalau saya, okay, you tengok sini, kalau saya kira gradient from 4 to 6 second, saya tahu pattern. You nampak shape of the graph here, the gradient must be negative value. Kenapa negative sedangkan velocity is increasing? Okay, because the object is moving in negative direction. Okay, jadi acceleration you dapat nanti, okay, adalah nilai negatif. Bukan sebab objek itu decelerate, the object is accelerating since the velocity is increasing, but the value of A is negative because the object is moving in negative direction. Remember, you jangan hafal A negative sebab dia decelerate. Somehow, when the object is moving in negative direction or in opposite direction, okay, masa V di increase, nilai A akan dapat negatif seperti contoh ini. Okay, so kalau tak percaya, kita boleh kira lah kita punya A from 4 to 6 second. So, look at here, this is the final point. This is the final point. So, negative 3 minus 0 for the y-axis, for the y-coordinate. And for the x1, 6 minus 4. Okay, so negative 3 minus 0 over 6 minus 4. And the answer is negative 1.5 meter per second squared. Alright, and then from 6 to 7 second. Okay, the last one. Look at here. This one. Okay, saya highlight sikit lah. Saya highlight dengan warna kuning. Biru lah biru. Okay, that one. Okay, so look at the number of the velocity from 3 to 1, 0. V is decreasing. Alright, V is decreasing, but the value of the velocity dekat mana graf ini? Dekat kawasan negative velocity. Means that the direction of the motion is in negative direction. Dia masih bergerak in negative direction. Okay, so kalau saya tulis dekat sini, for this one, V is decreasing, but this time, the object is moving in negative direction. V decreasing, that's mean dia decelerate. Tetapi bila kita kira nilai gradient of the graph, you can look at here the pattern of the gradient. Okay, so saya selalu ingatlah kalau you nampak pattern of the gradient macam ni, means that dia negatif lah. Kan, kalau dia macam ni, dia positif. Okay, so kalau saya nampak pattern of this graph, this is positive pattern. So, the acceleration kita kira nanti akan dapat nilai positif. Okay, nilai positif. Alright. So, means that even though V is decreasing, the object is decelerate, but the value of acceleration yang kita kira akan dapat positif because the motion is in negative direction. Okay, so the acceleration we can calculate 0. Sorry, I will change the color. Okay, 0. Minus negative 1, negative 3. Okay, over 7 minus 6. And the answer is 3 meter per second squared. So, bila kita dah kira, now we can sketch the graph. Alright, so this is the y-axis, which is the acceleration. Unit jangan lupa. And then this is the x-axis, which is t in second. Okay, and then you label all the time interval, 3 seconds, 4, and then this is 6 and 7. Alright, and then the acceleration, look at all the values yang kita kira. We're going to have 2 meter per second, negative 6, negative 1.5, and 3. Alright, so here we have 2, and this is 3, and we're going to have 1.5, negative 1.5, sorry, and we're going to have -6. Okay, you lukis lah elok-elok guna pembaris. Okay, oh sorry. Okay, this one. Okay, boleh lah. Okay, so kita ambil lah kita punya pembaris, ruler awak. So from 0 to 3 second, it is 2 meter per second squared. Okay, and then this is a dotted line. And then from 3 to 4, alright, 3 to 4, so it is -6. Okay, you got macam tu. And then from 4 to 6 seconds, it is negative, alright, -1.5 here. And the last one is 6 to 7, it is 3 meter per second squared. Okay, so finish question 3B. And the last one, alright, so now let's calculate the distance and displacement. So we have two questions here. So remember, distance is a scalar quantity and displacement is a vector quantity. So when you have graph of VT, okay, so when we calculate the area under the graph, ini area under the graph, ini pun area under the graph. Okay, bezanya this area under the graph will give you positive value, but this area of the graph will give you negative value if you consider to calculate the displacement traveled by the object. Kenapa? Sebab displacement adalah vector quantity. That's why, okay, bila vector quantity, we consider negative sign. Because velocity, negative sign of the velocity means that the object is moving in negative direction or opposite direction. Okay, ini sebab itu the area under the graph ini bagi you nilai positif. Maknanya kita tahu objek itu bergerak ke depan ataupun ke kanan ataupun in positive direction. But this time, this area you have negative area. Maksudnya mungkin dia patah balik, kan? So you kena tambah negatif. Okay, kita buat satu-satu. Okay, sebelum kita mula, saya nak kira dulu area under the graph. Okay, so saya akan labelkan dulu A and B. Okay, yang ke atas tu A, yang ke bawah B. Okay, so we start here. Okay, kita nak kira yang C dulu. Distance travel. Okay, ingat distance adalah scalar quantity. Alright, so kita nak kira area under the graph, but ignore the negative sign of the velocity. Sebab dia tak ada direction. Distance itu scalar quantity. Okay, ignore negative sign. So tulis kat sini. Okay, sebab apa? Sebab no direction. This is scalar quantity. Okay, so we calculate the area under the graph. Okay, area under the graph. Okay. Okay, so saya kira dulu yang A lah, area under the graph dia akan jadi sebab macam ni, area under the graph, A, okay, area A plus dengan area B. Okay, so the distance should be, A tu adalah triangle, right? So saya akan guna formula triangle lah. Half times 6, the height of the triangle, and then the base of the triangle is equal to 4. Okay, plus, okay, plus, we have another triangle. Okay, so kat sini, okay, tengok half, formula of the triangle, times the height. Height dia adalah -3, right? Look at this triangle. This should be -3. Tapi sebab kita nak kira distance, kita akan ambil 3 sahaja. Remember, darab dengan dia punya base. 7 minus 4, 3 lah. Okay, so you settlekan. The answer is 16.5 meter. So this is the answer. Okay. Tapi kalau kita nak kira displacement. Okay, displacement. Alright, so sama juga area under the graph, but this time we consider negative value of the velocity. Okay, of the velocity. So it should be S. Okay, formulanya sama. Sekejap. Okay, so we write, here we write S equal to, sama juga formulanya. Okay, triangle yang atas sama, salin saja balik, plus, okay, triangle yang bawah, plus, this time the height of the triangle should be -3. Itu beza dia. Kat sini kita ada -3, we consider negative sign of the velocity because this is displacement, vector quantity, and we consider direction. Okay, so you kira lah. Okay, you kira, you akan dapat the answer is 7.5 meter. Okay, so finish example number 3. Alright, example number 4. So let's read the question. A train pulls out of a station and accelerates steadily for 20 seconds until its velocity reaches 8 meter per second. Okay, so dia dah bagi masa lah ni. Okay, accelerate steadily for 20 seconds. It then travels at a constant velocity for 100 seconds. Constant velocity for 100 seconds. Then it decelerates steadily to rest in a further time of 30 seconds. So, question minta kita sketch a graph of VT graph. Okay, so for question A, okay, so we're going to have VT graph. So, V is in meter per second. Okay, and then T is in second. So, the time start from 0, and then dia dah bagi tahu dah. Dalam masa 20 second, they start from 0, right? Okay, and then they accelerate steadily, okay, sampai 8 meter per second, until it reach 8 meter per second. Okay, so here it should be 8. Okay, dalam masa 20 seconds. Okay, 20 seconds. Alahai, tak lurus. Awak buat cantik-cantik Okay. And then, dalam masa 10 second, dalam masa 100 second, that's mean from 20, tambah lagi 100 second. So, label tu mesti betul. 20 second plus another 100 second. So, here should be 120 seconds. Okay. Dia bergerak secara constant. Velocity dia tadi dah sampai 8 meter per second. And this time dia adalah constant. So, the constant straight line lah macam ini. Okay. Okay, macam ni lah. And then last sekali what happened? Dia decelerate steadily. Okay, maknanya bila dia kata decelerate, V dia decreasing lah. Okay, secara steadily tu maksudnya adalah deceleration dia adalah uniform. Straight line lah. Sampai dia until rest. In dalam masa 30 seconds, so 120 plus 30, so it should be equal to 150 here. So dia berkurang lah sampai point ini dia berkurang. Okay, dah siap kita punya graph. And then calculate the acceleration and distance travel in each part of the journey. Okay, so bila dia suruh kira each part of the journey, so kita nampak kita ada here we have 3 different sections ataupun 3 different path. Okay, so you can label the point. They say this is start from A lah, A. Saya namakan sini B, this point C, and this is T. Okay, so kita tulis satu-satu. Okay, for question B, from A to B. From A to B. Okay, acceleration ni kita nak kira kan? Acceleration and distance travel. Okay, kita kira dulu dia punya acceleration lah. Kan? Acceleration, which is the gradient of the graph, it should be 8 minus 0 over 20 minus 0, and then the answer is 0.4 meter per second squared. Okay, and then for the distance travel, okay, so you can calculate the area under the graph. Okay, area under VT graph tadilah. So kita akan dapat, okay kan, saya warnakan sikit. Okay, warna kuning ni. Sebab kita nak A to B saja, right? Okay, so it should be, okay, S equal to half times 20 times 8. Okay, so it is 80. Is it? Alright. So 80 meter. Okay. So dah dapat jawapan. Okay. And then from B to C, the velocity is constant. Okay. constant velocity means that acceleration dia 0. Tak perlu kira. The acceleration is automatically equal to 0. So this is the answer. And let's calculate this one. Okay. The area under the graph from B to C. Okay. Same goes to the previous one. Kita kira area under the graph, but this time the shape is square, right? Okay. So dia adalah 120 minus 20 is 100 here. This is 100. And this is 8. Kan? 8 kan panjang dia. Okay, darab 8. So the answer is 800 meter. Settle. Okay. And then we move the next part. Okay, which is from C to D. Okay, kalau kita nampak from C to D, dia decelerate, right? So the acceleration akan jadi negatif. Dia decelerate, tetapi nilai velocity tu masih dalam kawasan positive velocity. Maknanya dia masih bergerak ke kanan, tapi kali ini dia decelerate lah. So dia punya acceleration dia masih negatif. Okay. So saya akan kira acceleration. Okay, acceleration dia negatif. 0 minus 8 over 150 minus 120. So the answer is negative 0.27 meter per second squared. Okay. So saya dah dapat jawapan. Ni untuk yang biru lah. Kan C to D. Sorry. So C to D saya pakai colour biru. Okay. Meter per second squared. Okay. And then we will calculate the area under the graph. This one. Okay. The blue color. So triangle. So we want to calculate the distance. Okay. So half times 150 minus 120 should be 30 times the height of the triangle is 8. Okay. So it is 120 meter. Okay. So this is the answer for B. And then C, we want to calculate the average velocity. Okay. Average velocity. Kalau average velocity, macam mana kita nak kira? Okay. Means that total. Sorry. Kalau average velocity, macam mana kita nak kira? Okay. Kita tulis kat sini. Formula dia dulu. Average velocity is as final displacement minus final displacement minus initial displacement over time. Okay, time interval. And then remember, this is displacement. Okay, so kita boleh kira area under VT graph. Okay, for the whole journey, you can see here that the area, okay, berada pada kawasan positif lah. So kira yang ini saja untuk kesemua ini. Okay, for the whole journey from 0 to 150. Okay, from 0 to 150. Boleh ataupun you nak tambahkan semua ni pun boleh juga. Yang kita dah kira tadi 80 plus 800 plus 120. So it is equal to 1000 meter. Okay, so final displacement is 1000 meter minus initial 0 meter, and the time taken is 150 minus 0. So average velocity is equal to 6.7 meter per second. Okay, so this is the answer for question C. Alright, so now we finish discuss 4 questions for subtopic 2.1. And then for the next video, okay, we will try to discuss 2.2 under kinematics of linear motion. So kita akan discuss soalan dan menggunakan 4 equation linear motion. Okay, so jumpa lagi dalam next video. Assalamualaikum, bye bye.